In this video, we will be discussing how to graph quadratic functions and learn specific characteristics about them. Remember, quadratic functions are functions in the form y equals ax squared plus bx plus c. We're going to specifically be talking about this a value, which is the leading coefficient for a quadratic function. You will be expected to apply your knowledge moving forward, so pause and replay the video as needed. You are now entering a no ruler zone. In the past, we've graphed lines or linear functions so that you needed to create a line using a ruler. Now our graphs are going to have curves. So we are not going to connect the dots using a ruler. Instead, we're going to have to freehand in order to connect the dots. You should end up with a curved shape as opposed to a straight line. We're going to start out with something that we already know how to do, which is solve an equation using factoring. So we see that we have a trinomial here, and with trinomials, we should be thinking we're going to sum and product in order to factor it. We need two numbers that are going to multiply to -5 and add to +4. The two numbers that should come to mind are 5 and 1, and 5 minus 1 gives me 4, and 5 times -1 gives me -5. So going to what I know about factoring, I know that my quadratic has to be equal to 0 in order for me to solve it, so I'm ready to factor. And I'm going to split up x squared with x and x, and then I'm going to use these two numbers like we've discussed in our last unit to factor. So I have x plus 5 and x minus 1 as my factors. Now we've discussed moving past this in order to solve the equation. So I'm going to set each factor equal to 0. So x plus 5 equals 0. And I'm going to solve for x because when I am solving, I should always end up with x equals, and in this case, -5. I'm going to do the same thing by setting this factor equal to 0, adding 1 to both sides, and x is equal to 1. So the two solutions for this equation are x equals -5 and x equals 1. We are going to want to keep these solutions in mind because they are going to have a connection to the graph that we are going to create. So now we're going to look at the same exact function, but now we're going to look to graph it. Now we will not be graphing these by hand, so we're going to get this table from our calculator. Remember, when you go to your calculator and you want to create a graph, you should always start by going to the y equals button. So I'm going to push y equals, and I've already inputted the function x squared plus 4x minus 5 because that is the function we're going to graph. You guys are quick to go to the graph to see what it looks like, and you'll notice that it creates a U shape. This shape is not a V, so make sure that when you graph it, it has a curve to it. It is not two straight lines that connect at a point. But we don't really want to start by looking at the graph. We always want to start by looking at the table. And when I look at this table, I see a lot of random numbers. But if I look at a specific spot, like -7 to 3, I should notice that there's a pattern in the numbers I see in the y column. So that is why I have selected for you to graph the specific numbers -5 to 1. So this is showing me -7 to 3, but we will get the similar idea when we graph from -5 to 1. So please take a second to fill out the table and graph those points on your classwork. I will wait, so please pause the video. You should have gotten these numbers from your table on your graphing calculator. And if I plot those points, you'll see that it creates this U shape. Now, I have not connected my dots together for a reason. It does take practice, but you're trying to hit as many points as you possibly can. You also should never start at the end points, but start above so that your graph goes beyond your points. So I'm going to connect these points as best I can in creating what we call a parabola. And it's that U shape that you see. Don't forget, we should always label our graphs with a name. So I'm going to call this graph f of x. You absolutely can write the equation next to that, but you do not have to. So something you should notice in your table is this pattern that happens. These two numbers are the same. Similarly, these two match. These two also match. And then sandwiched between them is one point that doesn't have a pair. That is the point that we are going to call our vertex. The vertex is the turnaround point of my parabola. So it's this point right here that is my vertex. You cannot graph a parabola or a quadratic unless you have found the vertex. So the vertex is the most important point for you to find before you decide which numbers you're going to graph from your table. Some things you should notice is that you have a U-shaped parabola or a U-shaped function. It opens upwards, and what I mean is the opening is facing up towards the top higher y values. It has a y-intercept at -5, so that's where it crosses the y-axis. And it crosses the x-axis in two different places, where x equals -5 and where x equals 1. Remember, I had told you that those numbers are going to come up again. If I scroll up, you'll notice that these two solutions we found algebraically before are where the graph crosses the x-axis. So here it's going to cross at -5, and here it's going to cross at 1. So when we solve algebraically, what we're actually finding are the 2 points where our graph is going to cross the x-intercept or cross the x-axis. So let's bring this all together. Remember that a quadratic function is a function in the form y equals ax squared plus bx plus c. And remember, the x squared is the most important component of the equation. The graph of a quadratic is a U shape, and it is a curve that is called a parabola. The solutions that we find on our graph or from solving end up being called, there's a couple names for them. They're called the zeros, they're called the roots, and mathematically, they are where we cross the x-axis, so they're called the x-intercepts. All three of these names, or actually I guess 4, because sometimes you'll hear solutions as well. All 4 of these names are used interchangeably to talk about the place where your graph is going to cross the x-axis. In terms of knowing how to input this into your calculator, you're going to want to make sure that you put it into y equals. You always want to look in your table to find the vertex, which I like to call the sandwich, because it's sandwiched in between the two matches that continue to move outward. So you see this is a pair, this is a pair, this is a pair, and sandwiched right in between is what we call the vertex. You also want to have a minimum of at least 5 points when you graph, and you always need to include the vertex. So here's my vertex, and you want to have at least 2 points on either side of the vertex. I went beyond that, and I have 3 points on either side, but you want to have a minimum of 5 points in your graph. So now let's graph the function f of x equals x squared. So notice this equation is not really fancy. It doesn't have a b or c value. It's just a quadratic because it has an x squared. So go to y equals in your calculator, and you're going to want to type in x squared. Go to your table, and I'm asking you to graph from -3 to +3. So please pause the video, fill out your table, and then graph those points and check back in. So here you should have seen these numbers in your table. You'll notice again you have that pattern of matching pairs where in the middle our vertex is 0, 0. I'm going to connect these just to show you once again that we connect it in a curve. So I'm going to do the best I can with my cursor. Sometimes you might not hit them perfectly, but just do the best you can. I'm going to label this f of x. And in this case, it's asking me to identify the roots. Remember, the roots are our x-intercepts. Now, in this case, there's only one of them. It actually also ends up being our vertex. So here, the roots are at the point 0, 0, and how we write them is we write them just like a normal solution. So x equals 0 at this point. You always care about the x value where you hit the x-axis. Now we're going to move on to the next one, and you'll notice how this one says f of x equals negative x squared. Please go to your y equals in your calculator, graph this function, and then check back in to make sure that you graphed it correctly. Here's the graph of f of x equals negative x squared. You'll notice that this one also has a root at 0, 0. It also has a vertex at 0, 0. But this time, this graph looks like it seems to be facing a different direction. Now, I'd like you to predict, how do the functions above, both the first and second on this page, compare to each other? How do the comparisons affect the graph? We will get back to your prediction in a little bit, but for now, let's practice more graphing. Please graph the following in your notes or sketch as best you can, and then check back in to make sure that you're graphing appropriately. Here is the graph f of x equals 2x squared plus 8x plus 6. You'll notice I've identified the roots, which hit at -3 and -1. I have graphed the table, and I made sure in my table to include my vertex, which is that turnaround point. I also made sure that I labeled my graph, and I connected it in a curve. Here's another one. Let's try to graph f of x equals -2x squared minus 4x plus 6. Check back in to see how you did. So here's the solution, or the graph, and the zeros for this function. You'll notice that this one again seems like it's facing in a different direction. This might have something to do with the equations that I asked you to graph. So let's see if your prediction was correct. And if not, just make sure to fill out your notes so that you have the new characteristic of how these graphs compare to each other. When the a value, which is this number in front of x squared, is positive, your graph is going to open upwards and look like a U, like this red or pink U on the right. When your a value is negative, however, it's going to flip that parabola upside down. So now the opening is facing downwards. It almost looks like a lowercase n if you were to have to pick a letter in the alphabet. This is really important to know so that your graphs can identify with the a value in their equation. Remember, positive facing up because we're being positive, and negative facing down because we're being negative. In this video, we discussed how to graph quadratic functions and learned specific characteristics about them. You will need to be expected to apply this knowledge moving forward. So if you have any questions or need to rewatch the video to fully understand how to graph quadratic functions, please replay.